Assalamualaikum warahmatullahi wabarakatuh and good evening everyone. We are from group CS2512B. Today, me and my group want to explain and demonstrate about Apline Linux. First thing first, this is our group member. I will introduce myself. My name is Muhammad Ajid bin Ubadillah. The other three is my members, which is Muhammad Fayyad Amshar bin Muhammad Fizmi, Syahmi Fahmi bin Shahrizan, and Muhammad Ifan bin Zazali. For introductions, Apple Linux is a highly efficient, lightweight, and security-oriented Linux distribution designed to provide excellent performance while consuming minimum system resource. Unlike many other Linux distributions, it has a very small installation size, typically less than 200 MB, allowing it to boot quickly and run efficiently, even on systems with limited memory and storage. Due, due to its speeds and reliability and strong security features, Apple Linux is widely used in virtual machines, cloud computing environments, embedded systems, and Docker containers, making it a popular choice for developers and system administration.
So I'm gonna tell you why we chose Apline Linux and the history of target audience of Apline Linux. So why we choose Apline Linux? Because it is lightweight. It features a minimal storage footprint, drastically reducing image download time and speeding up application deployment in cloud environment. Also, it is highly secure, engineered with security protocol like position independent executable PIE and static machine protection SSP to mitigate vulnerabilities. It also, by including strictly essential package, Alpine boots almost instantly and ensure optimal frictionless resource allocation. So, about history and architecture, Alpine Linux. First released in 2005, Alpine is fully independent distribution rather than relying on standard GNU utilities. It utilizes mass and busybox to remain exceptionally compact, fast, and resource efficient. The target audience built specifically for system administration, device engineers, and cloud developers. It is the premier choice for modern, resource-constrained environments like embedded device and containerized architectures.
Now, I will begin the demonstration by starting the Apple Linux virtual machine. After the system finishes booting, I will log in using the root account to access the terminal. Once I am at the command line, I can begin checking at the operating system has started correctly. First, I will enter the command cat ctrl-os release to display the operating system information. After confirming the OS version, I will continue by typing uname A to check the kernel and system details. As you can see, both commands run successfully, showing that Apple Linux has booted properly and is ready for the next demonstration. So, for the scene 2, I will demonstrate how I use OpenRC in the Apple Linux. First, I open the terminal after logging into the first Apple Linux. Then I type the command rc status and press enter. The terminal displays the current status of the OpenRC service. Next, I enter RC service networking status to check whether the networking service was running. After that, I type RC update, show default to display the service configured to start automatically during boots. Finally, I use PSX head and press enter. This command show the first few running process on the system. These are basic command I run during the OpenRC walkthrough. That's all for the demonstration. Thank you.
Good day everyone. In this scene, I will demonstrate basic Linux file, the administration by creating a directory and a file, modifying file permission, changing file ownership, and finally performing a cleanup. First, I create a new directory by typing mkdir/tmp/csc520_demo. This command creates a directory named csc520_demo inside the /tmp directory, which is commonly used to store temporary files. Next, I create an empty text file inside the new directory by entering touch/tmp/csc520_demo/sample.txt. The touch command creates an empty file named sample.txt. To verify that both the directory and the file have been created successfully, I type ls-la/tmp/csc520_demo. The ls-la command displays all files, including hidden files, in a detailed format. It shows information such as file permission, owner, group, file size, and the last modification date. Next, I modify the file permission by entering chmod 640/tmp/csc520_demo/sample.txt. The permission value 640 means the owner has read and write permissions. The group has read only permission and all other users have no permissions. To verify the permission changes, I run ls-la/tmp/csc520_demo. The output should display the permission as -rw-r--- confirming that the changes have been applied successfully. Next, I change the ownership of the file by typing chown root will/tmp/csc520_demo/sample.txt. This command changes the file owner to root and the group to will. To verify the ownership change, I once again run ls-la/tmp/csc520_demo. The output should now show root as the owner and will as the group. Finally, after completing the demonstration, I clean up the files by deleting them. First, I remove the file using rm/tmp/csc520_demo/sample.txt. Then I remove the empty directory using rmdir/tmp/csc520_demo. This complete the demonstration for the scene 3, showing basic Linux file management, permission control, and ownership modification and cleanup. For the scene 4, network and process mapping, first I type IP address. This command displays all available network interfaces along with their assigned IP addresses. It is useful for checking whether the system is connected to a network and identifying the local IP address assigned to the virtual machine. Next, I enter IP route. This command displays the system routing table. The routing table determines how network traffic leaves the systems and shows the default gateway, which is responsible for forwarding traffic to other networks, including the internet. Finally, I type psax. This command lists every active process currently running on the operating system. It displays background services, application, and other system processes that are using system resources. System administrators commonly use this command to monitor system activity and troubleshoot running programs. This concludes the demonstration for scene 4. In this scene, I demonstrated how to inspect network interfaces, viewing the routing table, and monitor active system process using basic Linux command.
Now, let's look at the scene 5, which is package management and engine deployment. Let's look at the actual deployment step for engines, which we can break down into 3 phases: installing it, managing the service, and verifying our works. First, under package management and installation, we prepare the system. We run APK to refresh our catalog and get the latest software list. Then, we use APK search engines to confirm the server package is available on the repository. And finally, we run APK engines to download and install the web server onto our environment. Second, we move to service management and boot configuration. Just installing engine isn't enough. We need to turn it on. we run RC service engine to start. To kickstart the web server immediately in the background. To make sure it stays reliable, we run RC update and engine default, which tell the system to automatically launch engine whenever the server reboots. Finally, we need verification and testing. To ensure everything is operating smoothly, we run RC server engine status to confirm it is actively running right now. And we pipe RC update show default through a grep filter to confirm it successfully set to launch at hood. To finish up, we use quick grepjet command directed to add our local address by pulling and printing the raw HTML code of the file engine page directly onto the screen. We get instant undeniable proof that our web server is live and answering requests. Now it's a scene 6, user administration. Now let's look at how we create a new user and grant them administrative privilege, often known as a sudo right first. We use the user add command to create our new user student demo and set up their home directory. We then use password to securely assign them to a login password. Once the user exists, we need to add them to the wheel group using user mode. In Linux, the wheel group is standard shorthand for users allowed to run administrative tasks. We can quickly double check our work with the ID command, which confirm our user successfully belongs to the wheel group. Next, we actually have to tell the system what the wheel group is allowed to do. We write the configuration rule into the sudo directory, specifying that any user in the wheel group can execute any command. For security, we lock down this file permission using chmoad 440 so it can be easily modified by unauthorized user. Finally, we test it out. We switch into the new user account using su and attempt in admin task by running sudo wami. The system gives us the classic security warning about privacy and responsibility. Ask for our password. And once verified, output root. This proves our new user successfully has administrative authority.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amshah and I will introduce you guys about my Alpine Linux on firewall or security. Okay, so first, if we already installed the Alpine Linux, we must setting up a firewall because a very basic computer we must need a security, and then we hiring a security guard to protect a building, right? Alright, so in the beginning the system did not have the protection because the basic one we're not setting up the protection, we're not setting up the security firewall. So this part I'm going to put the security to increase the security from my Alpine Linux. Okay, so we use the program called UFW, which stands for uncomplicated firewall, because the security program requires various tools and libraries to function properly. The system automatically download and install 16 different pieces of software to get everything ready. Alright, so next, once the firewall was installed, we must comment on the Alpine Linux. Alright, so once the firewall is installed, it was give time to security guard specific instruction before waking them up, like before they start up to start their work on the Alpine Linux. Okay, so quick status check show that the firewall was currently inactive. Yeah, because the basic one we are not activated the firewall, so now we are activating it, and yeah, the guard was still sleeping, so it's not blocking any traffic when we start command. After we turn the up, okay, the first official rule given to the firewall was allow traffic. So they call specific gateway called port 80, which is the standard highway used for the regular website traffic. So an attempt was made to disable the computer to display an error message along with a helpful instruction menu. Okay, finally, when we put the after we put the command UFW command, we can get the security guard was officially put to work by turning on the firewall. Like, it's already turned on the firewall in our Alpine Linux. Okay, so a confirmation message appeared on the screen indicating that the firewall was now active and would automatically start protecting the system. Alright, so to make sure everything was running perfectly, a final command was typed to view the active role checklist. So we must become the local host, and then we must command UFW enable, so it's starting to protect the system from outside. Okay, so the list confirmed that the firewall is now successfully active and protecting the computer. It will block all unauthorized traffic from entering, except for any visitor trying to connect through port 80. That's all for the firewall explanation. Thank you. Alright, so now we are going to conclusion. We are going to conclude our project, which why we choose the Alpine Linux and what we already discover sepanjang we discover this Alpine Linux. Okay, so the first thing first is unmatched efficiency. Alpine relies on must leap and busybox. This is like the tools that we use to run the program, run the system. So it proved highly effective, delivering a robust Linux experience while maintaining an incredible small footprint. The second one is streamlined management. The APK package manager paired with the OpenRC. We are used the OpenRC system offer because it is intuitive, rapid and secure. Orchestration for service like Nginx and beyond. And the last one is the future of containers. It's extremely lightweight, nature and security first design solidify its position as the definitive choice for modern cloud computing, microservice and Docker ecosystem. So Alpine Linux is the best Linux or the best OS among others. So that's why we are using Alpine, because it's very effective and very lightweight. That's all for our project. Thank you.